He's hanging at this end.
Right. There we go. We are live.
Afternoon, guys.
Just give it a few minutes for everyone to jump in. Excuse me.
On that previous session, guys, I couldn't see the attendees, so I'm guessing we might have some people that were on the morning session with us this afternoon.
Well, we're just waiting for everyone to join the room, guys, so you'll have to look at our pretty faces and my isolation haircut just while we wait for everyone to get in the room.
I think we do this again. We could probably do a bigger gap between the two so people got a chance to go off and grab a cup of coffee.
Yeah. Well, it's your fault for making the one this morning run on too long.
Mine's empty.
Guys, just as you're joining us, if you have done a session before, just stick in the comments which ones you've done with us to give us an idea. We've done the Power Radio with Jenny, the one this morning. Just let us know. It's hard to keep track of who's done what with us. Daniel's done all of them. Brilliant.
You are?
So Daniel's done all of them. So can you see the chat box, Shirley?
I can now, yeah. I couldn't see it this morning.
So we've got a few repeaters here, I think.
Was that Nuno said it's his full session? Cheers, there's done a couple.
Yeah. First time for some of them, so well, I think a lot of you have done it with us before, so we'll keep the intros. So just while we're waiting for everyone to jump in, guys, I think we've got everyone kind of who's coming in the room now, so we've got quite a big turnout. So thanks for joining us, guys. For the very few that's not been on one before, my name's Ashcroft, and I work with Sygma, which is up there behind me. We're a specialist training provider in utility detection. So we do a range of courses from one-day cat and jenny courses. We do a 5-day utility mapping course in association with the survey skill. And Steve, who's with us today, is the teacher for that course down at the survey skill. Steve's my colleague, obviously. So we do a whole range of courses all around utility detection, and we do some of the higher level utility mapping qualifications as well. So a lot of it's usually practical based. So we're putting these webinars out just to share some of our knowledge with you. Very quickly, my personal background, this is like Steve really, but he's done it for longer. All I've done is utility location. My working life, I started with Radiodetection. We make the kit when I think I was just turning 20, so 1920. And Steve was actually my boss. He gave me a job there all them years ago, and we're still working together. So Steve's done it a lot longer than I have, and Steve taught me everything that I know. And I will let Steve introduce himself. Pass over to Steve.
Just your mic's not really muffly, but you haven't got your hand over the mic or anything, have you?
No.
That's clearer.
I'll just move a bit closer, shall I?
Yeah, that's better. Can you hear me okay?
Yeah.
Yeah. For you guys on the morning session, thanks for putting up with me again. For you guys that haven't or not met me before or been on one of my courses, I started this business in the 1970s. My dad was he was one of the first franchises or franchisees for electrification, which was a utility surveying franchise. So that's how I started out. I was a utility surveyor straight out of school. Electrification went on to become radio detection. It changed from a a franchise surveying company into a manufacturing sales organization. I don't need to introduce you guys to Radiodetection. Everybody knows that company. And like Pete, it's all I've ever done. Straight out of school into surveying, into using the kit, training, helping develop. Lived in the States for 4.5 years, worked all over Europe. So sad admission, but this is all I've ever done. I'm also getting a bit too old to do anything else. So this session, guys, is, if I put the screen share on now, if I'm doing it properly.
So what? Once again, guys, this is again a snippet, if you like, a section of the 5-day utility course that we run. And as I mentioned to some of you on the session this morning, I honestly believe this is one of the most important parts of it. It's a section on how a utility network works, how it gets from your power station to your house. And interestingly, what I find, a lot of the surveyors we train, they're a bit put off by this section initially. They want to get stuck into using the kit. But when they've been through it, they realise how valuable it is. It's so much easier to locate that network when you understand how it should work, what connects to what, and high voltage, low voltage, all that kind of stuff. So I hope we get quite a lot. I'm going to have to leave halfway through. My wife's at home with the kids trying to homeschool them, and I've been in the office for a few days, and the driving are absolutely mad. So I'm under instruction to get back and help us sort out our little terrorist. So I'm going to leave you in Steve's hands at some point halfway through this. So I will pass you over to Steve, who will get stuck. Again, guys, sorry, I should have said, I keep forgetting that some guys are new here. The way the software works is there's a little bit of a delay. So you hear what we say about 7 seconds to 10 seconds after we say it. We want to keep this session interactive. So we'll be asking you questions, and you're more than welcome to ask us questions and ask us to expand on things. But just bear in mind that delay. So it does mean there's a few pauses in between. If we do ask you a question, we kind of have to wait for that delay till we start seeing your answers. So just bear with us. We're making the best out of the software. But please do get involved. Keep it interactive. Stick some comments in there if you like. And I hope you enjoy the show. Over to you, Steve.
Yeah, thanks, Pete. When I started out in this business as a teenager, obviously working with the old man, he'd been doing it for a couple of years at this point. And the one thing that used to drive me mad was we used to walk over the site. In hindsight, and with the benefit of many years now experience, he was absolutely right. You kind of got a feel for your site. I appreciate that a lot of the surveyors nowadays don't have a lot of time. One of the jokes we have on the surveyor course is how much time do you have to do this job? In our day, we were fairly blessed with having plenty of time to do the job, but walking over your site, getting an idea of how things are, and it's what we call locating without a locator. The 5-day course that Pete keeps referring to, myself and Mike Langton devised this. It was originally a 3-week course, which kind of got condensed into 5 days, and we're now taking snippets out of it and putting on these webinar sessions. And it's tough to try and, this is only my second one, the first one this morning, it's tough to try and explain stuff without any kind of visual aids, and a lot of times we're actually going out onto site and explaining it, but I'll do my best. Chuck your thoughts, ideas up. I looked at the number of slides, I'm going to have to crack on. I'll try and skip through quite a few of these, but it is very useful to understand how your networks, and this is obviously based on the UK. We really don't have time to go into how the US and other countries connect. I don't know if we've got any anybody from the US yet. If they are, they're either up very late or up very early. But I noticed some of you guys, I think maybe in Australia, up late. But anyway, let's try and crack on with this. If I can get it working again. So this is predominantly obviously UK, and if any of you guys are from Ireland, Southern Ireland, believe it or not, it is somewhat different over there. So we're going to cover in this section, as Pete said, how electricity comes from a power station. In the background there you can see probably the most iconic power station in the UK, how it gets from there to plug, how gas gets from the North Sea to powering up your gas cooker boiler, how water comes from a reservoir to come out your tap, how it goes the other way from your drainage back to the water treatment works, how comms works, cable TV, broadband, and then obviously other, in this country, traffic signals, street furniture, all that kind of stuff. So This is done in the way that mostly TSA guidelines on how to do a survey. You guys might disagree, and of course, you've got your own ways of doing things. I'm not saying one's right or wrong. They always recommend you start with electrics first. To be honest, a lot of companies, and myself and my dad included, we always used to start with drainage first. And if that's the way you do it, that's great. Totally up to you. The logic of starting with electricity first, apart from drainage, it's one of the easiest things to find in most cases. And it kind of ticks that box. You've done that, you know what you've found. And then anything else you might be tracing could be, once you've marked up the electric, jumping onto that instead. So this is the logic behind it. Rightly or wrongly, this is the way it's been done. So we're going to cover electric first. Do you need to know this? Probably not. If you're working in a power station, it might be useful to just try and get a feel for how everything is. The other thing I would say with surveyors is that you're kind of a jack of all trades. One week you're on a maybe chemical works, industrial site, brownfield. You could be anywhere. And you might be talking to an electrical engineer one week who thinks that you know exactly what he's talking about. You might be talking to a pipelines engineer the following week. So this kind of gives you a bit of knowledge about everything. So in simple terms, and this is the same worldwide, you need a source of water to generate steam. This is how power stations work. And you need a source of heat to heat that water up to make the steam. So fuel, coal, wood, oil, gas, nuclear. It's a very simple process when you think about it. It's heating up steam. The steam drives the turbine drives the generator. In this country, most electricity is generated around about the 30 to 35 kV voltage. That is then transformed up to 400 kV. In other countries, other voltages, bigger countries, higher voltage. This is the first time I've looked at these. I don't know when peaks coming and going. But one of the questions I always ask surveyors, just out of interest, why do the generators generate such high voltages? Why is it not 240 volts? I'll leave you pondering that question as we carry on. Hydro is pretty much the same. If you guys are working up in Scotland and there's quite a lot of hydro, or anywhere where there is hydroelectric, you've got water flowing through a device called a penstock, which is basically just a tube which is turning the turbine's turning the generator. Same principle. This is more where I guess we come into it. Yeah, Kieran, you're right. Trying to look at that screen there, electrical distance. Absolutely. The reason it's such high voltage is because you get loss over distance. So if a power station produces 240 volts, by the time it's traveled, some cases in this country, a couple hundred miles, coming out of a plug socket, the voltage will be zero. So you've got these high voltages, which are then transformed down to usable voltages. So on the left-hand side there in yellow, you've got transmission. That's what we call, or used to call, this country EHV. And on the right-hand side in red, we've got distribution, which is then HV and LV. The definition in this country nowadays is anything over 1,000 volts is deemed HV. So if you're working on a site and it's 3.3, 6.6, there's some spurious voltages in Scotland. I think there's some 1.1 and maybe 2.2 kV. The other thing I'm assuming, guys, that you understand that when I'm talking about K, we're talking about 1,000. So 33 kV is 33,000. 11K is 11,000. So you've obviously got your transmission side and then distribution. So you've got a power station generating in this country 400 kV, which is pretty common. It's then transformed down as it goes around the network. There's one voltage missing there, which is 275, but you can have 400 kV dropping down to 132, 33. Large industrial units, big sites, factories are going to be taking in 33 kV and transforming it down. So you guys might be working on the private side of that. So it comes in through the local electric company or even National Grid in some cases, and then internally it's private suppliers. This is where surveyors often have a lot of problems, because on the private side you may have no records, no plans, nobody's got a clue where stuff is. In the streets, it's going to be predominantly 11 kV. So if you walk down the average street in the UK, there's going to be an 11 kV substation somewhere. Probably the worst place is going to be London. If any of you guys work in London, you have my utmost respect, because it's probably the worst place you can ever think of working. Trying to find a substation is the hardest thing. You can have it on a plan and you're walking up down the street trying to find a substation, and it's usually because it's underground. Other countries probably have very similar things, but walk down a fairly small English town or city, you can spot an 11 kV substation a mile away, but try that in a major city like London, that's not quite so easy. So in the UK, this is part of our survey course test, but on the transmission side, we've got 400 down to 132 kV. On the distribution side, you might occasionally come across some 275 kV, but that goes all the way down to 3.3. And then one of the major high voltage system in the UK is on the rail network. Some of you guys probably do work on or near the track. It's probably the second worst environment to working in this country, working on any network rail infrastructure where there's 25 kV. And you guys will know why. If we get a chance, we'll talk about that later. And again, if you are working on those networks, it's a fairly simple system. You've got 25 kV overhead. The neutral is the track. So it's a single phase supply coming into the switchgear, as you can see in front of you, going up overhead. This is just, again, for information. And then once it gets transformed down in your average street, you've got a distribution network. So the bigger cable on the right-hand side there is the supply in from the transformer, using the old color coding of red, yellow, blue. We haven't got time to go through phasing on this, to be honest with you, but you've got 3 phases. So each one of those white things there, there's a few. So if you ever find yourself, and it's less likely nowadays, in the old days with me and the old fella, they used to just give us keys to substations and tell us not to kill ourselves, which miraculously we didn't. So each one of those white things is a fuse. So you'll have a number of businesses, houses, properties connected across a fuse. European countries very often have 3-phase supplies coming in, but in this country it's just single phase. So you've got one cable and neutral, and in the older systems, earth. So as far as you're concerned, if you find yourself in a substation, you're keeping away from this stuff and looking down here, maybe getting a signal clamp around, that kind of stuff for tracing out. So in this country, the National Grid owns the transmission system. If you're looking at old networks, old marker posts, signs, records, you'll still come across CEGB, and that's the Central Electricity Generating Board, which is now National Grid. These figures are out of date because as we speak down in this part of the world, they're updating the 400 kV network from Hinkley Point to Avonmouth, so that's going to increase the number of 400 kV and 275 grid. When you look at those figures, guys, those figures are fairly small compared to the LV network or the distribution network, which is massive by comparison. On our 5-day course, we didn't used to do too much about transmission cables because there's very few of them around, and most of them are on pylons. And you can kind of work out where those are. You don't need to be a surveyor to work that one out unless it's foggy. But once they start bugging it underground, you've got a major issue. Number one issue is cost. It's depending on which figures you look at, up to 20 to 30 times more expensive. And if there's anybody from National Grid here, they can give me an absolute figure. But you're looking at huge amounts of cost sticking these things underground, and dissipation of heat, and obviously protecting it. Pete, you popped in just then. Did you want to make a comment, or were you just going?
No, I think you're going to cover it anyway. I was just going to say, is it worth covering here? I'm thinking of things like oil-filled cables and gas-filled cables, and why they do that, and why they prefer them to be overhead. That was what I was going to touch on, but I think you
started. No, that's fine. Yeah, I'm kind of mindful of how it went this morning and how many slides I've got. Yeah, so if you're looking at drawings and you see oil-filled or gas-filled cable, and you're thinking, why on earth are they oil-filled? Coolant. These things get hot underground, and they've got to keep these things cool. Obviously, when they're on a pylon on a tower, they're naturally air-cooled. So they're not insulated, they're just bare wire. So climbing up a pylon and grabbing hold of one, if you've seen any of the videos, is not a very clever idea. So yeah, there's issue with keeping these things cooled. National Grid is starting to use, and a lot of other companies are starting to use XLPE, where there's no coolant. The XLPE actually dissipates the heat. I said to you just a minute ago, we didn't used to do a lot on transmission cables because there aren't many around. And then a guy on the course a few years ago said to me, we're having a major issue tracing out some National Grid cables. And I suddenly thought, we need to kind of explain why they're such a pain to find. You'd think they'd be dead easy, 400 kV, 275 kV. There's a couple of factors. SBLs is one. An SBL is a sheath voltage limiter. Because of such high voltages, you get massive amounts of induced power onto the arm of a cable. I put a post up on LinkedIn and our Facebook utility page a while ago of fiber optic cable that was arcing. That arcing was caused by induced 60 hertz. It was in the States. So imagine when you've got the outside of a cable, which is next to 400 kV single core, you're getting a huge amount of induced voltage. So what an SBL does is it basically blocks this from going to Earth. So as far as we're concerned, as locators, there isn't technically an Earth path for our signal to travel down. From an electrical safety point of view, there is. If my memory serves me well, it's around about 3 to 3.5 kV. Above that, it dumps it to Earth. So if there's ever an issue with Earth problems, there is an Earth, but when the locator's trying to put a signal onto it, there isn't. The other issue is, I'll show you a picture of a joint bay in a minute, but at the joint bays, the cables are all connected together. You can see from that, these links between the joints. So if you do manage to get a signal on one cable, and these cables are laid side by side, I'll show you a picture in a minute. You get a signal on one, it's going to transfer across to the other two. So we've tried all sorts to get decent traces on these, and sometimes you can only really trace them using high frequency, which is not the preferred method, but sometimes the only option. And of course, you've got no access to them, so it's naturally induction. So this came from National Grid. Gives you an idea. You might be using your GPR to find these. According to National Grid, there will be 1 meter minimum cover. Whether this is the case or not is anybody's guess. You've then got roughly a width of about 1 to 1.4 meters where the cable is going to be installed, then roughly between 3.5 and 5 meter separation. So if you look at that, that's the same kind of configuration as a pylon. It's just that it's buried in the ground rather than on a tower. So 1, 2, 3, and the same down here. 1, 2, 3, same again. So this is exactly the same configuration as a pylon. I'm not saying you should take this as gospel, but it kind of gives you an idea of the separation. So if you are struggling with the electromagnetic EM locators, your GPR may well be picking up the excavation, the trenching, the troughing, the tiling, whichever way it's being buried, and you should get an idea of separation. That, looking at separation, I would guess is 275 kV, because I don't think there's enough separation between those to be 400 kV. You'll notice, guys, there's a 4th cable in there. I'm sure the experienced surveyors here will have looked on plans and seen reference to P or pilot. So with certainly transmission and even down to 11 kV in some cases, you'll see pilot cables. Pilot is like a comms cable. It's monitoring things like oil pressure, switch gear, all kinds of stuff. So in simple terms, it's like an alarm cable. So wherever you see high voltage cables, you'll very often see pilot cables alongside it. I mean, that is just going to trace as a bank. You're going to struggle to get those individually, unless you guys know something I don't. And believe it or not, that is actually a joint bay. We'll show you some joints on some smaller cables, and if you've seen joints on LV, they can be very, very small. But a joint bay for transmission cables is that kind of size. And that's what it looks like in the ground. So those are your joints. It's done under very clinical conditions, and you can see the cables connecting them all together. So you've managed to get a signal on this one by some means. You're going to get signals on that one and that one. It's an issue I've noticed with the 8000 receivers. If you guys have tried this before, you can't turn them down low enough. I've been stood on top of those sorts of cables on power with the gain at 0, and it's off the scale. This is something the manufacturer needs to address. The VLOC Pro 3 has addressed it to a certain degree. You can actually pick them up, albeit not very easily. But this is a problem that you're going to get with, especially if you're working in national grid substations. A lot of the guys have been in this business a long time. They used to keep the old RD400s, the old PXLs. They used to work pretty well in a national grid substation. And Ben, you're saying you've had the same issue. Yeah, I know it's a problem. Just keep badgering the manufacturer to work on it, I guess. I don't know how clearly you can see that, guys, but that is a on marker post, very valid. Voltage in this country used to be known as tension. So you had high tension and low tension. So I don't know how clear you can see that, but that says high tension cable, pilot cable, CGB. These old marker posts are very, very valuable. If you're on industrial sites, you may well see these kind of concrete markers. And that's an old Yorkshire electricity joint post indicating where the high voltage cables were jointed. So have a look around for obvious features. Going down to who owns what again. Back in my day when I first started, it was the boards, and you'll probably hear the old farts like me refer to the electric board, Lecky board. They were government-run organisations, not profitable, run by shareholders as they are nowadays. When they flogged them all off, they became RECs, regional electricity companies. So you might hear people refer to the RECs. Then they became NOCs. The current name is a DNO, distribution network operator. So in my part of the world, Western Power, who used to be SWEB, South Western Electricity Board, took over the whole of pretty much the Midlands, East Midlands, Wales, South Wales. So they combined. And if you're out on site, guys, you're still going to come across all the old MEB, East Midlands Electricity Board. If you're in London, LEB. I was up in Birmingham the other day and came across an old Birmingham something electric company link box cover. And you may well find in London, you're going to find some old lids that might be some of the old London boroughs before it. And the boards were founded in the 1930s, if my memory serves me well. I don't know if we've got any electrical guys on here. But don't forget, there's going to be some old stuff out there. It's still very valid. It's just a case of trying to work out what's what. That 500,000 kilometers of underground cable is well out of date by now. It's probably closer to 750, 800,000, and 450,000 substations is probably, again, well out of date by now. These are some fairly common abbreviations that the electric industry use, and there's so many of them. Whenever I do the 5-day course, I've got a whole load of booklets. I mean, you can get a lot of these online. There's some of them they don't make anymore, but if you get records from UKPN, you get a booklet with it, which is for whichever region it's in, and there's a whole bunch of abbreviations, terminology, symbology. These are just some of the common abbreviations you're going to come across. Cable type, conductor type, features like pot ends, link boxes, that kind of thing. It is very valid or useful to know what kind of cable you're looking at. So triplex, you surveyors out there, you'll know this. It's a pain to try and trace accurately.
Ben's just asking, Steve, is that worldwide or UK in regards to the abbreviation?
It's going to be UK or wherever the UK built a network, but you'll probably find, and this is true around the UK, that even the different regions, so SWEB, South West Electricity Board, which is my electric provider down in Bristol, there's different terminology and abbreviations between here and Bridgewater. If any of you guys have ever been to Bridgewater, I don't recommend it, but my apologies come from Bridgewater, but it's only about 20 miles down the road. But they use different terminology. So same company, different terminology, different abbreviations. So some are standard, Ben, but I wouldn't take them as gospel.
And this is the other, again, I think I was touching on this on the summer sessions I did today.
But we're thinking of doing actually a planned session. But one of the other issues in the UK, when Steve was showing you that, if you just go back a couple of slides, Steve, just to that map, that one there. So if you have a look at that, they're the different providers, and your plans will come from these. And to give you an example, if I get an Electricity Northwest plan, the LV on it is orange. If I get a Western Power plan, the LV on it is blue. If I get an SSE plan for Scotland, North of Scotland, the LV is green. Scottish Power is brown. It's a joke, really, but all these different regions, it's a nightmare trying to look at the plans, and especially for the guys that are out there excavating. If they're working on near a border area, one day they could be in one region, the day after they're in a different region, and they've got completely different plans, completely different colours. And even UKPN alone, so UK Power Networks, you can be in Kent and get a UKPN plan, and the LV's green. You can be in central London, get a UKPN plan, and if you're lucky and it's new, the LV will be blue. If you're unlucky and it's old, it's black, which is the same colour as the bloody curb line and boundary line and stuff. So, you know, the standard of plans in the UK are terrible. And before I hand you back to Steve, just to finish off, Steve mentioned some books and stuff, and also I should have said this on this morning's call. We've got a lot of old material, PDFs and stuff. I'm going to stick my email in the comments box, guys. If you want to drop us an email, if there's any of these books you fancy reading or something, then drop us an email, and I'll pass it back to Steve.
Just to qualify what Pete said, he's absolutely right. And we've had some online spats, and I owe UKPN a phone call because after one of my online spats, they did actually ask me if I could go and have a meeting with them, which is I think would be very valid. In the southeastern part, they've got some excellent plans. That's the old seaboard area. So some of their records are very, very good. It's like all regions. Some are good, some are bad. The one thing surveyors, and this is something that I keep on harping on about survey, you cannot do your job without a decent set of plans. I suppose I should qualify that. You can do your job, but I certainly wouldn't want to. The other thing to remember is also there's a lot up there that says independent network operators. So you've got the likes of GTC, SSE, and there's lots of them out there now. They're putting a lot more detail on their plans, including services to properties, including gas service to properties. How accurate they are, I'm not sure. But anyway. So HV distribution, everything's done in threes. Again, we talk about color coding on plans. There's actually no real color coding for the stuff in the ground. I always show people the picture of the cables in blue before it actually pops up with what it is, because most people look at a bit of blue plastic in the ground and just assume it's a water pipe. There are blue plastic covered HV cables in the ground in this country. There are also yellow, and the yellow ones, there aren't many of them around, but they do look remarkably like gas pipe. So if you've come across an old Hessian covered thing, it's anybody's guess what it is. Probably a cable, but it could be an old Hessian wrapped pipe. If it's lead, same again. I've got samples of these when we do the 5-day course, and we pass them around so people can have a look at them. On a cable in this country, they are embossed. If it's plastic and it's modern, as you can see down here, 6.6 kV, that's not very easy to spot down a trench covered in mud. But it does say on it what it is. If you find yourself in a substation, which is less and less likely nowadays, and I've worked in substations up to 400 kV, pretty much everything. But we used to get access to substations because it was the quickest and easier way of tracing out. But each one of those is a circuit breaker, and that's just a switch. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I can't count. There's 5 breakers there. So if you were tracing out, you need to go around the back of there, look for where the cable goes in the ground, and use your signal clamp. You don't need to know about a circuit breaker truck. If there was such a thing in this country, that is an average 11 kV distribution substation. And whilst we say don't take this as gospel, generally, when you look at a substation from the front on, your HV would usually be on the right, and the LV would usually be on the left. So that would give you a clue. If that can, if your plans confirm that as well, then great. That may be your only option for tracing out the HV. Once you've done the LV, induction on the right-hand side of sub might be your only option. That's the same, but an outdoor sub, and that's the same configuration. HV is part of a ring main circuit, so 2 HVs, and then some LVs over here. I would use different colours bang at a time. If any of you guys have got a good or decent eyesight and you've spotted it, there is a signal clamp around the LV cable. All manufacturers of locating kit make extension rods for your signal clamps, which allow you to screw it onto the clamp. Very quickly. I was told to go to full screen view, but to save time, there's I think it's an 8mm thread, it might be 6mm. That you can screw an extension rod in there, and I'm not recommending you do this, but it does allow you to access things you might not be able to reach. You don't need to know too much about an LV panel. That's something we cover on the 5-day course. So going back to this same picture you saw earlier on. So the transformer, 11 kV out here somewhere, may well be in the same building. And then that's your LV supply coming in from the transformer. And if you do find yourself in a sub, this will tell you where these cables are going. Again, I wouldn't take it as gospel. Should be relatively accurate, but so I'll give you a clue as to where things are supposed to be going if you find yourself in an LV distribution substation, which increasingly is probably very unlikely nowadays, unless you're working on behalf of the power companies. One thing that surprises me when we do a surveyor course is the number of people who don't know what link boxes are. Not always under a lid that says electricity supply. Very often it's just a concrete lid that looks very much like a comms box. What I recommend nowadays, gents, is you don't lift that lid beyond that point, because underneath that bell housing is live contacts. I was doing a basic cat engineering course in Birmingham years ago, and a surveying company had been along, and we went out to site to do the practical bit, and there was a double link box, which you can always tell because there's 2 lids side by side. On the survey drawings, they had 1 cable in and 1 cable out. That would imply to me that they didn't have the original plans. And I said to the guys straight away, you've got to be very, very careful here, because that's a double link box. That means you've probably got 4 in, 4 out. Without plans, it's hard to tell. Which goes back to the obviously necessity of always having plans. So that's how simple link box is. And then the name link box is what it is. It links one bit of a network to another. In this country, it's all about keeping people on supply and meters going round. So if they want to work on a bit of cable and they want to keep people on supply, they pull fuses at one substation, put the links in, and that whole link or that cable from that link box is now livened up, and they can work on the sub. So it's actually linking substations and bits of network together. That's what they are. The other thing is, if you ever come across a link box that's smoking, I would contact the electric company if I were you. And keep well away from them. They are notoriously unreliable. And Neil's put their boom, yeah, it's pretty.
Just to jump in there, guys, I don't know if anybody was on the what happens when you hit a cable session with me yesterday. You might remember one of the last videos I showed you with the guy on the phone on the corner of the street and the explosion. That was a link box that had blown up. So that's what I was referring to yesterday when I mentioned the link box.
Yeah, look in the comments. Yeah, Steve. Yeah, it is through the fence technique. We don't recommend you do that, by the way. Nowadays, we're going to put all these disclaimers in. And Neil, you're absolutely spot on. Yeah, they are very dangerous. These pictures were taken with an old digital camera, one of the very first ones that ever came out in this country, and we were given unfettered access to substations. I did a lot of work in the power industry back in those days.
Sorry,
right, Pete.
Michael.
Things were very different in those days. So this was taken with the old Kodak KDC-40 digital camera. We did tons and tons of substation work, not only on tracing out, but on circuit breaker testing, phasing, all kinds of stuff. Yeah, you probably don't get that much access. The only place I've found that seem to be fairly relaxed are big industrial sites, places like big chemical works. Martin, if he's on, I don't know if he's on today, but I did a bit of mentoring with Martin Marshall from Sygma when he was working for a surveying company on, I think it was Warwick Uni. And he said to me, right, we're off to do the 33s today. I said, how the hell are we going to do that then, Martin? He said, well, just go in the substation. And we did. The obvious disclaimer to that is you shouldn't be in these places unless you are authorised and trained and you know what you're doing. If you come across a substation like that, which I did in Wiltshire, that's dead handy. Signal clamp, round the cables, dead easy to work out. And you generally consider, and you'll be able to see on the side that the red would be 11 kV. Don't be surprised if you come across some black 11 kVs and some black 33s as well. And there's the old dreaded triplex, polymeric HV, American. That's the first time I ever saw that was in my back garden in Houston in the 1980s. They were putting some new cable in, 13.8 kV to my transformer, the transformer in my back garden. But awful stuff to trace. We've tried all sorts over the years to get a decent trace on that stuff. The obvious problem when you put a clamp around that is you're introducing into 3 different cables, and if you put it around one, you get cancellation effect, which we actually never got around to covering on this morning's session. And in power, you're going to get the most hideous distortion. Pete may have covered this on a previous session, but we call it the Mickey Mouse ears effect. You get a magnetic field that looks like Mickey Mouse's ears. So that means you get a trace over there, and that was also on this morning's session, but I didn't get around to run the video. Don't be surprised if that happens. And omnidirectional fields, what you very often find with triplex is you turn the receiver around as if you were trying to find a sonde, and it gives you the right position. It's impossible to measure, model in 2 dimensions. We tried to do it and it just looks like a mess. But think about a ball-shaped field rather than a cylindrical field for those of you that are used to these sort of things. And the other problem with triplex is that the guys, when they install it, they're supposed to cable tie it. So here the cores are splayed out, here they're close together, splayed out. So as you walk down the pavement, especially on power, you're going to get different signals every metre or so. Yeah, you put in there, Neil, nice to see the depth. Yeah, look where the marker tape is there, and it's on foam concrete. Everything about that picture is wrong. You put concrete over cables, and that marker tape should be up here somewhere. But anyway, Pete will cover more of that on his other Cat and Jenny type courses. The obvious thing to say about this, got a bit of CAS or SAS, smooth aluminium sheath or corrugated aluminium sheath. So if you've got a signal coming from this direction, you've got one signal there coming off the outside of that cable, because that's what your signal clamp puts it into, or your induction. It goes through the joint. You've now got 3 signals this side. So don't be surprised when you get different signals as you're walking down the route of things, because there's actually 3 separate cables. They are cable tied at this point, but you're still going to get a weird signal beyond that joint. This is one we've used. I actually took that picture. You can see my shadow there. Same again, you've got a breech joint here, old Hessian cable. So going to triplex in and out. All I can say is if you're trying to trace those, good luck. Without access to those cables, and even if you did have access to those cables, you're going to get signal on this one and signal on that one. They're very close together, massive amounts of distortion. If this one disappears off around the corner, great. But if it parallels the other one, you've got 2 signals in very close proximity, all kinds of weird results. The only thing you can do there is try tracing from different positions. You'll see lots of old clay pot joints in the ground, which of course, if you've not been in this business a long time, you think is maybe drainage, especially some of the old straight joints, because they just look like a bit of clay pipe. That is an old-fashioned but fairly common T-joint, service joint, believe it or not. So you've got your mains LV coming through,
Question in, Steve. Jessie's just asking, will the stats plan show if it's triplex or not?
Yes. If they are the genuine original plans from the electric company, yes. One of my pet hates is, sorry if you're in this business, but overlay plans, where somebody's taken all that information and transposed it onto one drawing. The reason it's my pet hate is because you lose all the original information. If you've got the original information, great. It will say on electric plan 3CX, that's a copper screen triplex, 3AX, that's aluminium screen triplex. It might say 3 times 1. It might even say triplex or triplex. I don't know what it's a bit like Linux and Linux. I've never quite worked out which one it is, but anyway.
I think it also it depends on the area. Going back to what I said before, Jess, the regions are different. For example, UKPN, on some of their plans, will actually give you cross-sectional supplementary sheets which indicate that better. But I think it's region by region, isn't it, Steve? I'm sure I've seen a few electric drawings where it doesn't show if it's triplex or not, depending on the area. It's not always on the, I think, depending on which region it's in. I'm pretty sure on the modern Scottish Power ones it doesn't show it. Could be wrong, but I guess I wouldn't expect it to always be there. I don't think it will always be on, depending on the region. Is my view on that.
Yeah, I think you're right to say don't guarantee it, but I would say most of them I've seen it's on there. I wouldn't vouch for its accuracy. That's the other problem, which is another pet hate of mine and Pete's. If you've ever seen some of our LinkedIn rants, but anyway. Yeah, Steve, you're right. 3 times XLPE is very common as a indicator that it's triplex. I'm just very mindful of time, guys, and how many slides to get through. This is very, very uncommon in most street situations. This was my eldest son was doing a survey in Cardiff, and we lifted what we thought was. He asked me to go help him just because. It was a nice sunny day. I decided I'd go give him a hand, and we lifted what we thought was a drainage cover, and there were the LV cables. So that's an old-fashioned cast iron LV joint, but signal clamp extension rod. I mean, you don't have to buy the manufacturer's one; you can make up your own. I knew a guy that used to work for one of the highways companies, made up one. He proudly showed me a bit of 3-meter copper pipe that he'd used, which I wouldn't recommend, but a nice long bit of plastic with a male bolt epoxied in the end is dead handy. And most of the manufacturers make the signal clamps with extra long cables, up to about 15 meters, I think is the longest you can get. Or you can just make up an adapter in some cases. Not for the RD stuff, by the way, because that plugs too much of a pain, but for the VVAX ones, it's fairly simple. A couple of breech joints here on an LV network with a service connection, if you can just about make it out, going off to the streetlight column. So if you're applying a signal here, that would trace back here. You can imagine what that's going to trace like. You're wondering where the hell it's going as it weaves its way around. Of course, with the smaller cables, it does loop around all over the place. With a bigger cable, you can't bend it around quite so easily. But that's not going to be shown like that on a survey. Sorry, on a stat plan, if it's even shown at all. That's the other problem, is whether those are shown on plans or not. A ferrule mixture there of old and new, very old-fashioned leaded T-joint. Obviously, the name T is because they look a bit like a letter T. Resin joint. That's a PME breech joint. So service coming off to a street light, off to a column somewhere, and then a PME earth in the ground. I always ask the guys on the survey course, what's that? Is it HV or LV? Mindful of time. Yeah, I like your idea, Jez, using a zip tie and a broom handle. Yeah, I've done that as well. Or gaffer tape. Because the CD clamp, for whatever reason, they decided not to put a thread on it. So I've had to do exactly the same thing with that. Mindful of time, gents, I'm going to tell you, if you don't know, that's both. That's both HV and LV. So coming up the pole, you're wondering what relevance is that to underground surveying? Well, coming up the pole is triplex. So that will be disappearing off down underground. It's coming up and then it's going to the transformer, and then you've got LV overhead. This doesn't probably show very well, but in this country, generally on an overhead pole, LV is strung vertically and HV is horizontal. I wouldn't take that as gospel, but generally that's the case. The other thing to look out for in this case, you've got 3 phases and 4 wires. That kind of gives it away as well. Yeah, you're right, Steve. And Neil, yeah.
Just while you carry on, Steve, I'll just chuck a question and you can think about why you're moving on. Why is there 4 wires on an LV and 3 on a HV? I'll leave that one with you guys. What's the difference as Steve moves on?
Yeah, and just to qualify that, you might only have 2 on the HV as well. If it's a spur off down to a farm, it could just be 2 cores. Anyway, so on the left-hand side, horizontal HV. And if memory serves me correctly, if you were stood with your back to substation looking at this, is totally irrelevant, but if you stood to substation with your back to substation, the nearest to the right was red phase, yellow, blue. I could be wrong if there's any electrical engineers out there that still remember the old phasing. On the right hand side, again, you can see the 4 cores. The other thing, when you're looking at these poles and somebody's saying, is that HV or is that LV? Yeah, that's very obviously HV. It's horizontally strung. That used to be a red cable. If you've ever owned a red car and it's been left out all summer and you've not polished it, it goes pink and then eventually bleached white. So that was once a red cable, 11 kV. On this side, there's 2 things that again immediately give it away besides the configuration of the overhead. Street lighting and BT. You cannot have BT or street furniture on an HV pole in this country. It's illegal. You can have LV and HV on the same pole, but you can't have other services like BT. So there's BT on it. And again, from a surveyor's point of view, if you want to know what the relevance is, if you look closely, there's a whole load of cables disappearing underground. And like I had the problem yesterday with leaded cables, if you end up with anything like that, and I haven't seen a star joint like that in years. This was in Sheffield with YE, Yorkshire Electricity, or YB as it was in those days. Just imagine you're trying to trace that from one direction, and you see it disappears off in all kinds of different directions, and it's touching all these other cables. Let's hope that most of those have been replaced with modern plastic cable. So a very standard electrical distribution layout in a street. You've got your substation, HVs in the configuration I was saying, HVs on right, LVs on left as you're looking straight at the substation door. You've then got an LV cable going down the street with service joints, T-joints, feeding properties, feeding street lights. Link box over here. Service connections to properties. You can tell how old this plan is because it references white phase. If you look on a drawing and you've got letters at each property, it's the phasing. So blue phase, white phase, red phase. Down in Bristol, we had some where it was red, green, blue. So you've got green. Nowadays, it's now grey, grey, and grey, or whatever the colours are. And eventually, it gets to your property through a consumer cutout if you're tracing out in the streets. So modern properties, little white box on the side. Somebody put a joke on one of the Facebook or LinkedIn posts saying that's 2 metre separation. Get it? Electric meter, gas meter? No, maybe not. My joke's not very good in survey course. So. Anyway, there's one very obvious difference between those two. On the right-hand side, a very old 3-phase cable coming into a property with just single phase coming off it. So in the good old days, there was big old chunky cable, big solid earths. On the left-hand side, you talk to the gas lads or the utility lads, and they talk about bootlaces because the cable's a tiny bit of cable. You can chop through it with a shovel. The one on the right, you'd have to really try to chop through that. But anyway. Street lighting. Pete's covered this on his Count Jenny course, but for those of you that have not done that, I'm sure most of the surveyors know this, but there's two configurations in this country, and sometimes a mixture of both. Top configuration, loop in, loop out, so it goes from column to column. Bottom configuration, teed off. You may well find in certain town centres it's teed off, and then maybe a couple of road signs, bollards, columns are fed column to column. On this Electricity Northwest plan, it shows you the street lighting SL, and the top one here, red, yellow, blue, three-phase supply into that column for whatever reason. Red phase, this one. So that shows you that it's fed directly off the mains. So that's a good access point for us to be able to trace out the LV main. Same again here, red phase, directly off the mains. This is very common in this country. Most residential streets, South Wales for whatever reason tends to be slightly different, but generally you'd expect to find most town, city centres, residential streets, street lighting is fed direct off the mains, but it's a great way of accessing the LV network. This is South Wales. So that tiny little purplish, magenta, whatever colour you want to call that, blob there on that Western Power plan is that feeder pillar. Inside that feeder pillar, that's your incomer, and then you've got three cables going out. These are obviously not shown on the Western Power plan because they don't own them. I don't recommend you do what I did and open up the cabinets. I have been trained to do that, and I do have the documentation somewhere, but God knows where. But it does allow you quick access to the cables. Having said that, if you lift that cover next to it, you'll see all the cables in there anyway, apart from the LV incomer. So this street's got a right old mixture of old and new. So over this side, LV main. From this cabinet here, the cables actually come out of here, go across the road and feed down this pavement and feed all the street lighting down there. On this side, the street light column is fed straight off the LV main. So it's a bit of an old mixture of old and new. I do a lot of work on cable fault detection in retail parks and business parks. Those are a law unto themselves. You'll find any old configuration of whatever somebody decided to do at whatever moment in time. So in this situation, we've got loop in, loop out, jointed. All I can say is if you find yourself on those sort of places, again, good luck, because it's whatever somebody decided to do. There seems to be a logic to it, but I wouldn't guarantee it. Again, if you've been trained and you've got the authorization to do so, popping off the streetlight covers, very quick and easy way of finding out how many cables you're looking for and how it's configured. One cable on both of those, either the last cable on a run or fed directly off the mains. Cheers, Jess.
Steve, can I just jump in for a quick second? I've got a dash now, so I just want to say bye as well. I've got to go home and do my bit with the kids. So I just wanted to say before I went, guys, there's quite a few more sessions coming up. There's 3 tomorrow on the Cat and Jenny side of it. Steve's got another one next week on EM. I don't know if you saw the email, but we've got Mike Langton from Mala doing some GPR stuff next Monday, Wednesday, and Friday. But anyway, the point is, if you've not got the mailing list or the links, just email me and I'll get it over to you guys. So I might see some of you tomorrow on some of the sessions, but I'll leave you in Steve's capable hands, guys. You've got my email. It's there again if you want to get any updates on the future sessions. Thanks for joining us, and I will see you later. See you later, Steve.
Thanks, Pete. I'm not sure where he gets cable hands from, but anyway, thanks for you guys who are staying. I'm going to have to crack on with this because these webinars are only a 2-hour session, and if you guys really want to stay for 2 hours, you're welcome to, but if you want to dip out. But I'm kind of struggling for time now, which I tend to find that I do on the survey course. So yeah, you guys need to shoot off. That's great. Thanks for your time, and hope some of it's been useful. Certainly dip into Mike's GPR session because they're very useful. So again, this is a combination of where it's fed in from an LV main and then feeding out from the column to other columns or bollards, road signs, street lighting. The one thing to say with columns, gents, this is consistent. Wherever the metal access plate is, the cable comes out directly below. There's a hole in the column. If you've ever seen one of these things out the ground, that's where the cables come out. So if you do have the authorization and access to do so, and you pop the covers out, and you can see how many cables there are, you know exactly where those cables are coming out of the column. So in this situation here, I would be putting my transmitter there, using the magnet onto the back of the column, and then that gives me the ability to walk around the whole front of the column and work out where the cables are going. What you don't want to be doing is putting your box next to the column and running your earth across it, because you're just going to end up picking up your earth leads and your connection leads. If you're in a big retail park, look out for the feeder pillars cabinets, because that's where they're all going to be, all the lighting's going to be fed from. These sort of things, illuminated signs, boards, street lighting in the background. It's just time consuming, basically. That's the problem. Yeah, G39 training. You're right, Neil. That's what you need to get to be able to go into these. I mean, that gives you access to all those cables. Or you could just use the old tried and trusted technique, find a column. The thing with these guys, you're not going to have any plans for these. You might be very lucky and find that somebody's done a schematic, but these are not going to be on utility plans. So, working in busy town city centres, have a look on the top and see if there's a photocell. Because if there is, reasonable chance that that's going to be solar powered, obviously. If this is a card machine, then it's going to have some sort of comms link to it. But this gives it away. That's an earth rod. So that parking meter in a London street is mains powered, just like the street lights. Same with bus shelters. You've got a bus shelter, mains cable running down the pavement, feed off to the shelter. Probably the worst is a BT phone box. I've no idea what people use BT phone boxes for nowadays. If you're caught short on a night out, I think in Worcester they use them for cash machines. In some places they use them for libraries, but there is a main supply which is fed directly off the LV. So that's normally how it's configured. Mains LV cable down the pavement, feed off to bus shelter, feed off into a building, feed off to a phone box. Clipping onto the phone box won't trace that cable, I'm afraid. There are techniques which we cover in the surveyor course, but I haven't got time to cover it today. There are ways of doing it. I also wouldn't recommend doing what I did and dismantle a BT phone box. But in desperation, that's what I had to do. So on the right-hand side, there's the LV supply and there's the BT cable. If it's a modern BT open reach, Virgin Media cabinet, most of these, the modern ones anyway, are mains powered. You can tell because there's usually a danger death sign on and you hear them humming away. So in the case of these, you can probably connect on and get a signal. What are you saying, Steve, to her first? Okay. GATSOs, in the good old days, they were just filmed, but nowadays they are connected up to a network. This is dead easy for tracing these out. With bollards like that, you've got a metal base around the bollard, clip your lead onto that, transmitter here, earth pin on the floor, water, we covered that on this morning session. That will trace that out. Same with the GATSO, it's probably fed from this feeder pillar over here. You've got all kinds of other mains power, street furniture, advertising boards nowadays. This is Bristol City Centre with all these funny little fountains and these uplighters. You can either get wet or just wait till the fountain's not on and just clip onto that. These are obviously going to be fed somehow between each other, off to a feeder pillar or from a column somewhere, presumably feeder pillar. I'm whizzing through, gents, because of time. Comms, probably the simplest thing in this country is cable TV. We always have a debate on the surveyor course as to how much detail you go into as to whether you trace every single one. I mean, it's doable, it's just massively time consuming. So you start out with a central office, cable office, where you've got a whole load of satellite dishes, and then you've got a bunch of manholes, cabinets, ultimately ending up through a swept T into the property. What I recommend is that you look at the Virgin plans, work out which is the last house on the run, get a signal on that one, trace that out, because everything else is going to go back to the nearest cabinet. It won't be configured in any other way. So that's your quickest way of doing it. Find the last property and trace it that way. You could put a clamp on every single one of those. I don't know why you'd want to, but you could, and that would take you best part of a day. So in the street, you can have the cabinet, manholes, swept T, connection to property. Obviously, it's going to be ducted, most commonly in green duct. Generally, if you're looking at ducting in a footpath, the connection to properties will be in the nearest duct to the boundary line, and the fibre is going to be nearest to the road. A swept T is called a swept T because it's not actually a T shape. It's like almost a Y shape, if you like, and that is going to go to the nearest cabinet. So if that's the last house on the run and you can get a signal on that, you don't need to trace all the rest. You just look at the next swept T and just draw that in. I'm not saying that's how you should do it. That's just the quickest way of tracing everything out. So BT obviously is our major comms provider besides Virgin Media, and there's lots more popping up nowadays. These are, again, common abbreviations you'll find in the comms industry. There's tons and tons of them, but these are the most common ones. It tells you how many ducts are in the ground. Electric companies often use that as well. 2-way, 3-way, 4-way. DPs are things to look out for, because the DP gives you access to being able to trace the BT. And the DP could be anything from a plastic box to a little metal, almost looks like a little oval shape metal box. And that looks a bit phallic, but you know what I mean. And maybe a BT reference number on it. And you can, if it's metal, clip onto it and get a signal on the BT cables. You're going to have questions as to, can you find fibre optics? Well, the simple answer is no, because fibre optics is glass, but the cable itself, it depends on what it is. The furthest I've ever traced anything was in the States on fibre optics, and we traced a signal 66 miles. You may well try and trace fibre optics in this country and not get any signal on it at all, because there isn't anything metallic in it. So it depends on what it is, whether it's blown fibre. So the bottom picture there is BT blown fibre. As the name implies, the fibre strands are blown through it. If you look closely, you might just be able to see it's like a foil barrier around it. You can, in theory, get a signal onto that. You're absolutely right, Neil. Don't take the cover off a DP. What he's saying is don't take the covers off distribution points, DPs. Similarly, there's a debate on lifting BT lids. Some companies put it on their plans saying we do not lift BT lids, and the reason for that, it's illegal. You guys may or may not know this, but lifting a BT lid is deemed an offence, and you can, in theory, get done for it. We've asked BT numerous times for a definitive answer, and they've never given us one. So some areas you might get away with it, some areas you might not. Going back to the fibre, it depends on the type of fibre cable. BT blown fibre you might trace. The latest thing, and there's lots of companies out there, but I've seen some GigaClear stuff, which is quite common around our part of the world. The fibre drops the property. This is not supposed to be rude. It's not as big as my finger. It's plastic tube, 7mm. How on earth you're supposed to find that is beyond me. You're not going to pick that up with a GPR. You can't put anything down it. We're just storing up tons and tons of problems for surveying companies, people digging their own garden in the future. But anyway, if the cable is a fairly major trunk type cable, it will have some sort of metal in it, either through the center for a strength member or maybe around the outside for an armoring. So obviously if it's that type of cable, you've got a chance of being able to trace it. And if any of you guys work down the West Country, you're going to know about these, because there's some major comms links between us and the US and parts of Europe coming off the Cornish and Devon beaches. The two big ones are Sennen and Bude Beach, which are the main transatlantic links to the US. Those cables then run up, I think, the A30 or the A38, I can't remember, or both. And They are our major US links. Those are easily traceable. Then you've got twisted pair. As the name implies, it's a pair of wires twisted. So that's what could predominantly currently fires up your landline if you still use one. BT drops to a property. You can trace it, but you're going to have to use high frequency. We haven't got time to cover it on this course, but or this webinar, but Pete covers it and I'm covering it on other bits. But in the States, if we've got anybody from the States here, comms cables in this country aren't in the property, but they are in the US. And you've got like a ribbon cable coming into your property, which is your coax and your twisted pair. I am whizzing through these guys because I'm very mindful of time. So my apologies for shooting through some of this stuff, but you might be glad of it. But anyway, traffic signals. In most major city centres, it's relatively simple to work out where they are because you've normally got the plastic lid boxes. They're not always plastic lid, but a box which sometimes says traffic signals, sometimes doesn't. We always have a debate on a surveyor course. Do you mark up the induction loops? If you've never seen these things, it's what tells the traffic light to change. A lot of systems are changing now anyway, where you've got the sensors on the camera. Sorry, the sensors on the light picking up traffic movement. But in the good old days, you had an induction loop right just underneath the surface. You can pick it up with a locator or GPR. It's just a case of whether you do all those or not, because technically it's an underground service utility, but have you got time to actually trace all those out? I don't know. We've covered gas, so I'm not going to cover that again. In the good old days, the CCTV cameras, when they first went in, they used to share ducts with the comms companies, but now you may well find that everything's all separate. If you want to trace those out, in places like supermarket car parks, I've traced loads of those. Clipping onto the metalwork will normally trace them out. You may well have to use high frequency to actually get a signal. In ease of tracing, high pressure pipelines are dead simple. It's a case of getting a signal onto that high pressure pipeline somehow. You'll have very good records for these, and you'll have indications where there's going to be CP posts. What do they carry? Well, we haven't got any interesting pipelines in this country, but in Denmark, Germany, and now Belgium, there are beer pipelines. For one very obvious reason, they drink lots of beer, and that's the quickest way of getting beer from a brewery into a city centre. So I'm going to skip over that one. So of the high pressure pipelines in this country, you've got the LineWatch website, which gives you not all of them, but a fair old number of them, telling you where the pipelines are, who owns them, what they are. All of these pipelines are welded steel, which makes them dead easy to trace. There's currently about 14,000 kilometres of these pipelines in the ground of the ones that are in the LineWatch network. And there's a network interconnected between Scotland and Ireland and Northern Ireland. When Mike and I did this course originally, we debated how much information to give you guys on pipelines, and this is going to be a very, very short section on CP. Yeah, Lee, I'll be with you on that one. Striking a beer pipeline, or certainly tapping into it. But anyway, so every pipeline, HP or high pressure transmission type pipelines, welded steel construction, so they are continuously electrically metal or electrically connected. They are coated with something called tar wrap. Nowadays, maybe epoxy wrap. The good thing is that this coating stops the signal from leaking to earth. That means the second longest thing I've ever traced is a pipeline. I've done pipeline traces of 15, 20 miles. The pipe itself is cathodically protected. This is the bit that Mike and I debated on how much information to give to you guys. Again, to try and help you talk sensibly to maybe pipeline engineers, and they're talking about CP. Very, very briefly, you've got two types of CP, sacrificial or galvanic anode system. How do you find using CP mode? Oh, yeah, Lee. The CPS mode on a receiver's, it's not a con, it's just not very good. If you guys have tried CPS mode on a receiver, basically it's in this country just picking up 100 hertz. So it's picking up the unrectified AC. It's basically, for want of better terms, power mode, but just a harmonic, which is great if you're in the middle of nowhere, but if you're in a city centre, it's useless because you'll only pick up power cables instead. The trouble is that a lot of the manufacturers sell it as a way of finding high pressure pipelines. And as I said, rural, yeah, no problem at all. But rural, you'll find it with bog standard CAT on power radio. What you get with the CPS mode is it acts like an active frequency in that you get the option of switching between peak and null. You get your direction indicator, depths and things like that. I certainly wouldn't rely on it, but if it was in the middle of nowhere, it'll probably be fine. Going back to the two different types, you're going to have a CP post somewhere on the network. So it's either going to be impressed current or sacrificial anode. In simple terms, it's stopping the pipe from rotting. So if you get a point where a farmer's put a fence post through the in the ground and taking some of the coating off, it's protecting the pipe from corrosion by reversing the flow of electrons along the pipe. So that's what you're going to look out for. CP posts, I'm sure you've seen plenty of those in your working lives. There may be a terminal on the side. If not, the terminals will be underneath here. And these things normally just pop off. And then you'll see the wires inside. And that's, if you can see it, it says pipe on that one. On the other side, it may well say anode or sleeve. If there's no labeling on it, you just clip onto it. If it don't work, you go on to the next one. See if that works. Yeah, they're saying that they were only using CPS. Risky. I've done lots of training with the transmission guys, and they didn't realise that it was going to just pick up power in most places. It's okay again in rural areas, but I wouldn't use it personally. I just clip on, much more reliable. Use CD as well, nice low frequency, current direction. So gas from beach to house. So it comes in from the North Sea. We're running out of time, guys. It comes into a gas terminal. The first thing they do in the gas terminal is dry it because it's fairly wet. They inject an odor into it. I'm guessing you guys know this, but natural gas has no odor. So what you're smelling is a chemical. I can't remember what it is, but I'm sure there's a gas engineer out there will tell us. Then they pump it up to very high pressure, which liquefies it. In the same way that we need high voltage to get electricity to travel around the country, we need high pressure to get gas to do the same. And in a very similar scenario to electric, you've then got pressure reduction stations and governors, which is reducing and regulating pressure. And ultimately, it ends up feeding a house. You would be amazed at the number of people who think that's detectable. That's an identifier. It is not a copper strip. You can't put a signal into it. Polyethylene is porous, gents. So where pipe is used in areas of contamination, high water table, they use a pipe with a membrane around it, and that membrane stops the ingress of water and or contaminants, and that's what the brown strip is. It's the membrane pipe. It's not for tracing. So if you've got anybody out there on site that says, oh, you can find that stuff because it's got a copper strip in it, you can't. Thanks, Ben, for the information, telling us what chemical is in the pipe. I'm a captain, if I can see that correctly. Again, some fairly common abbreviations that you'll find in the gas industry. I mean, there's hundreds and hundreds of them, but that's also color coding. So on most plans, this is one thing that the gas industry did do when it was transcode, standardized. So on the gas drawing, red's low pressure, blue with single dots is medium. We need to change that because it's got dashes and dots in it. Green's intermediate, and yellow or purple is high pressure. From a surveyor's point of view, you need to look out and see if it's the metal or plastics as to how you're going to find it. Gas is one of the hardest things to locate without a locator because there's very, very few indications. what every gas company will tell you is the same. But the gas goes into the property. If you can see that and you know where the gas main is, that will take the shortest route from there to there. On modern GTC, SSE gas and the other independent gas providers, they are putting gas service indications on their plans. Whether they're accurate, I don't know. Gas and water are the same. You've got a top connection coming off the pipe for obvious reasons, because that's where it's cleanest. I had a guy come on a surveyor course once. He was a service tracer for one of the highways companies. And I always ask the guys what their main reason for coming on the surveyor course was. And he said, I need to know how to find gas services because my boss is complaining I'm not finding gas services. I said to him, at the end of this course, you'll find out, or you'll be able to explain to him why you can't find gas services. But a gas main down at 700 down with a 25mm bit of pipe coming off it, and it's been mould in, you're not going to find that with anything other than a nice big 360 machine, I'm afraid. Unless you can bung something down it. If any of you guys are very good with dowsing rods, you might be able to find it that way around, but gas is probably one of the worst things, second to water, plastic water, meter down, mould in service. Nothing's going to find that unless you've got an old RD500, you might pick it up with that. That was a picture I took on a Cat and Jenny course. Asked a bunch of guys what it was. One of the guys said it was a recycling bin, upside down. When I pointed out it's got a lock on it and it's on a concrete base, he changed his mind. Anytime you're out on site, guys, you see one of those, you know you've got medium pressure gas. So a lot of rural sites, you might be in a rural village, town, all the gas coming in is going to be IP. It's going to be IP up to the boundary, and then it's going to be like having a little mini transformer on the edge of your boundary, and then that will reduce the pressure. Although that's all metal, everything below that's going to be plastic. So even though you can pop those covers off, the point to make when you're doing anything to do with gas, petrol stations, chemical plants, none of this kit is intrinsically safe. So yeah, you're right, Neil, it is the gas governor. So if you start connecting things on there, there's a chance of a spark, and if there's a pocket of gas there, you might end up blowing yourself up. So another disclaimer, obviously don't go messing around with stuff unless you've been authorized and it's safe to do so. And clipping onto that's a waste of time anyway. Look out for the old marker boards, sorry, posts. That's an old Eastern gas board, EGB. I would ask you guys if you know what it is, but it says the top left hand side there, it's an old siphon marker post. All the old stuff was imperial, so that's a measurement to the old siphon, which is 19 feet away. Just so you can again talk sensibly to the guys you might be working with in the gas industry. If we've got some guys on from the gas industry, you'll know these anyway. That's a very old siphon. As the name implies, it allows you to siphon water out. You'd think that the pressure inside a gas pipe will keep the water out, but firstly, the gas is fairly damp in the first place. Secondly, you've got water ingress, so you get quite a lot of water ingress into gas pipes, so that allows them to siphon it out. In the good old days, we used to use those siphon connections because they were metal down to the pipe, and we could actually trace out using that, but of course that's pretty much gone nowadays. And if anybody ever digs that up and says, what the hell's that? That would have been a siphon connection there. So the water gathers and then sits down in the sump. There would have been a pipe up to a siphon connection where you could siphon it out. And we used to clip onto those to actually trace out the pipe. It might give you a clue as to roughly where the main is if you still come across siphons, but who knows. Water, guys, I'm not going to explain the water side to you guys. Pipes and materials are similar to gas. The good thing about water is there's tons of surface features. Water has the one exception. There is various brands who make PE pipe with a metal barrier. The one on the left-hand side is Protector Line. I think there's a new company out there. The obvious thing to say, if it's got the metal barrier, it's theoretically detectable, but in reality, you might not. In Anglian water, so East Anglia, use a lot of AC mains, asbestos cement. So if you've got AC, non-metallic, you've got two options. GPR, probably 3 if you want to use dowsing. That's probably a whole nother webinar somewhere. But anyway, RD500. I haven't got time to cover the RD500 on this, but I've traced tons and tons of non-metallic pipes using RD500. Common abbreviations on the left-hand side there, and a fairly standard type distribution network. But the good thing about that, as you can see, you've got stopcocks, sluice valves, washouts, hydrants, tons of surface features. So locating without a locator on water tends to be a lot simpler because you can look at where things are and work out what's where it should be. So stopcock going towards a property, you know the water main has to be that side. It doesn't guarantee where, but you know it's got to be that side somewhere. We used to say that in the good old days, and this was generally considered true, that a fire hydrant was in line with the main. I wouldn't take that as gospel nowadays, but and this is why. So main's going that way, hydrant box is going to be that way around. So that completely messes up that theory. But it used to be that would give you an idea of the direction of the main. This will obviously, obviously it should be shown on a drawing. This is a bypass. And the guys that work in the water and see if anybody's on here that did or does, you'll know about bypasses and pressure reduction valves, and everything metal should theoretically trace out. I mean, you've got bolted flanges there. Anyway, obviously where you've got plastic, you've got no chance, but if it's metal, you've got a chance of tracing it out, and it should be shown on a drawing. This, you've got virtually no chance of finding. This is not a very good picture. I apologise for this. If you look down on this, these are very common in modern builds. Each one of these is a service. You'll see in a second. I think this picture coming up showing it. That's the service connection going off to various properties. There you go. That's the one. So you get your main. Sometimes it comes in like that. Sometimes it comes in this way, and then it feeds out. I did some tracing on one of those on a site in Nottingham and failed absolutely dismally. Even with the RD500, GPR was no good. The 500 is worth a try, but it's very, very difficult to pick those up. This tells us straight away where things are. Again, I wouldn't use it as gospel, but you've got an indicator. We cover this on a survey course. I'm guessing you guys know what the numbers mean. Top number is, guys. I'm just waiting for the comments to refresh. I don't know what sort of delays on this. When I had Pete with me before, he was reading the messages while I was rambling. The letters indicate what the feature is. So obviously H for fire hydrant, SV sluice valve, stop valve, whatever you want to call it. The technical term is sluice valve, but a lot of people on stop valves. Top number is size of pipe, and we've got a right on mixture. There we go. Yeah, Dean, you've come up with top is pipe size, correct. Bottom number, as you can see there, a mixture. Yeah, absolutely, Dean. Size and distance. Yeah, Matt, you've got the same. Ben, I'm from Australia, so no idea. So in this country, your top number is always your size of pipe, and the bottom number is how far away is it. A lot of people think it's depth. It's got nothing to do with depth. It's distance. It gives you a clue as to where the feature is or was. So you don't very often see them mixed. So if it's old, it's imperial. So we've got 3 inches, 5 feet away, and then top one. That wouldn't be 100 inches. Could be a bloody big pipe if it was. So it's millimeters and meters. You do occasionally see a mixture of imperial and metric, but so straight away here, I can tell what pipes where and size. So 8 inch, 4 feet away, 4 inch, 3 feet away. So the hydrant's off the 8 inch. So without a locator, you can say, right, okay, we know where those pipes are. That's assuming the council aren't going to move those posts, of course. Old pipes have depth. Old plates have depth. Yeah, you might find occasionally there are some with depth on. There could be the odd one or two. Predominantly they aren't, but yeah, I'm not saying never. I've been in this business long enough to never say never. I'm guessing you guys know what a washout is, WO. Australian colleagues may not. A washout and a hydrant's the same thing. The only differentiation really in this country is the fire brigades maintain the hydrants, the water company maintain the washouts, but they are technically the same thing. And if the fire brigade can't find a hydrant, they use a washout. It's exactly the same thing. AB, air valve. Just like gas pipes get water in, water pipes get air in. So if you ever walk past an automated air valve when it's gone off, it makes you jump very often, especially after a few pints on a stumble home from the pub, because it can often make a feral clunk and a strange noise. But anyway, these give you lots and lots of surface indications as to where things are, and obviously stopcocks at properties. So you can kind of work out quite easily where the water network is by the surface features. I wouldn't say it's gospel and guaranteed, but drainage guys. So very often surveying companies do this first, and we used to, for the obvious reason that we might be a two-man team on site, and I'm guessing that you guys, unless you've got the proper lifters, you need 2 people to do a lift. So we might do the drainage first, and then the old man go off and do something else, play golf, and leave me to finish off. So we do the drainage first. Again, you get some fairly common abbreviations, which I'm guessing are probably similar around the world, but I wouldn't take that as gospel. In this country, they do tend generally to use standardized colors on drawings, unless it's a company which has got a combined water and sewage system, in which case the colors could well be different. But red would normally be a combined sewer, blue would be surface water, and fairly logically turd color brown would be foul. So on that drawing there, it's showing us schematic generally, size of pipe, flow direction, materials. In the US, to this day, and having lived there for years, and I don't know if anybody is on here from the US, you can explain why, but predominantly all drainage from property is cast iron. It's only when it gets to the main, it becomes non-metallic. To this day, I don't know why, and this is why you've got 512 hertz and 640 hertz sondes. If you put a 33K or an 8K sonde into a cast iron pipe, the signal disappears. If you put a low frequency sonde in, you can pick it up. There are other techniques for finding sondes in metal pipes, which we can't cover today because we don't have time, and it's another course, but or another webinar anyway. But I don't know what it's like in Australia, whether it's cast iron to the main sewer or standard type ceramic clay type pipe or fibrous type pipe. But generally it's quite simple with drainage. You've got surface features, you've got what we call a soil stacker or a drain vent, as it says in there, which is what allows air to come into your drainage system as you're letting drainage go down into the main sewer, and it's gravity fed. Fairly simple. On a modern house built in this country, you will have separate surface water and foul, because that is the regulation. It may well then go into combined sewer out in the street, but that's what is required. So you might have a couple of different manholes with surface water and foul sewer. You surveyors out there, you may well have your own company guidelines on what you need to know to the sewer, and you may well do predominantly sewer type surveys. generally what we tend to look for in a manhole is which way is the flow going, invert levels, size of part, materials, construction, that kind of thing. Believe it or not, even though it looks like that flexi trace is going in the flow direction, I have actually seen builders put those the wrong way around when they don't know which way the thing's supposed to be going. So I wouldn't say it's common, but you might think that that's flowing that way, when in reality it's flowing that way. The only way you're going to find out is when somebody flushes a toilet and you see a bit of bog paper floating past, or just pour some water down and see which way it goes. Like I say, you may well do manhole surveys and record a lot more information than that, but that's just basic stuff. And you may well, to save time, use sounding rather than sticking stuff down it to trace out the connectivity between manholes. So a fairly simple separate foul and surface water system. This is one very good reason for, on a hot sunny day, not going for a swim in a river downstream of a fairly major city. And anybody that swims in the Thames wants their head examining, because the whole drainage system in London is currently a combined system. That means that when it rains and the gullies start taking the surface water away, at some stage there's got to be a way of getting rid of that excess water, because otherwise it would overwhelm the surface or the wastewater treatment plant. So they do that by way of CSOs. So a CSO, combined sewer overflow, there are all kinds of different CSOs. So basically you've got surface water and foul sewage in the same pipe, and you want to get rid of the surface water, and it does it by way of overflowing. Top picture there, a very nice Victorian type London brick built sewer. That thing will probably last 1,000 years and still look as good as that. So the one at the top there on the right hand side is foul, and basically that eventually just overflows when it gets too full, and that bottom one goes out to the Thames. The idea is that the solids are less likely to slop over. You might find on some sewage systems screens like the picture down below, which is trying to block some of the more undesirable things that you find in drains. But that's how a CSO system works. Obviously not every drainage system has the luxury of gravity, so you might be in areas where they've got to pump it. So in this country we call them pumping or rising mains. In the US they tend to call them force mains, but it's pressurized drainage. Again, from a surveyor's point of view, not easy to trace. We used to have very small sondes that were pretty much considered sacrificial. You could stick a load of bog paper around it and flush it down a bog. The only difficult bit of that was knowing when the pumps were going to kick in, and if it went off like a rocket, trying to find the solid thing again. But you can find just about anything on the internet relating to anything you could ever dream about, except pumping mains. I did eventually find this picture. So drainage is coming in from this side into a nice big holding tank, wet well. When it gets to a certain level, the pump kicks in, which is either a centrifugal pump or in some cases compressed. It's then pumped out the other side. So that's how you get you-know-what to flow uphill. And I'm sure you're all impressed by that little graphic showing a rising main or pumping main or force main. Gravity flow in, wet well fills up, pump pumps it out. So you might well be in a building with these funny looking things. That's compressors. That's what's pumping the sewage. And of course, going back to materials and tracing out, a lot of non-metallic stuff. So you may well find some old AC stuff, PVC. Yorkshire Water used quite a few PVC pipes until they realised they fractured. Polyethylene, cast iron, you'd probably still find some cast iron, ductile. I've traced a couple of cast iron rising mains in South Wales fairly recently with the VVAX kit. We did about 1.5 kilometres, which surprised me as well. And I've actually, by whizzing through, managed to speed up a bit, guys. This is only my second one, the first one this morning, so I wasn't quite sure of time, and I was getting kind of nervous as to running over because we've only got a 2-hour period on this. If there's anything you think we should have covered that we haven't covered, you want to go over again, by all means, put them up in the comments. This was leading on to the second part of what we do on the surveyor course, which we weren't planning on covering here. If there's anything you want me to go through particularly, stick them up in the comments. If there's stuff we haven't covered you think we should have covered, again, please comment away. And if there's stuff that you want me to do in more detail, I'll see what I can do. We've got 16 minutes remaining. Thanks, Ben. That's nice to know. I'm guessing a lot of you surveyors already know all this stuff. It's always handy to have a bit of a reminder, a refresher sometimes. And some of it might not be relevant to your country. Most countries, and I've worked in most, the one place I've not worked is Oz. Would like to at some stage. Certainly Europe's very similar to the UK. I've worked in most of Europe. The US, not dissimilar. The main difference in the US is CP to the property. And when I was out there in the 80s, it's probably changed now, but of course a lot of steel pipes, so it's dead easy to find. Thanks for the comments, guys. I'll just hang around here a little bit longer and ramble. If you guys got anything at all you want to ask, by all means do. Come down anytime. Thanks, Ben. I'm getting a little bit old to do it. I can help your guys do it. One thing I found, surveying is a young man's job. Talking about it is my age, because it does your back in, especially bending over, putting paint on the ground. But thanks for the comments, guys. I hope you found it useful. Enjoy the rest of your day, or in Oz's case, evening. I'll leave this open just a little bit longer in case you guys have got any thoughts or comments, and then I'm going to go get a bit of lunch because I didn't have time between the two and I'm desperate for coffee. Like I said earlier on, Pete's going to cover some other stuff. We may well put up a basic electrical theory because that's really useful understanding how any bit of location equipment works. Mike's courses on GPR are brilliant. They're always good. The downside of obviously this is we can't go out and show you the practical side of it, but if you can combine some of the stuff that you have already been trained on, allied with any little snippets you might have picked up on, little ideas, especially when Mike starts doing his GPR stuff as well, because you and I know that GPR is not a magic wand, great accessory to what we use. If you guys have got any ideas for the magic wand, I'm looking for a very good retirement plan, so I'll happily go into business with you. Until then, we're back to working out how dowsing works. If any of you guys have got any good ideas, let me know. Thanks for the comments, guys. Cheers, Jordan. Cheers, Lee. Cheers, Christian, Matthew, Ian. Catch Mike's webinar later on. Even Pete's stuff on Cat and Jenny's still very useful because it's really back to basic stuff. Stay safe out there, stay in lockdown. I don't know about you guys, but it's nice and sunny here today. So one thing, totally unconnected, and I get nothing from this, but for you golfers out there, my Optishot 2 golf simulator turned up yesterday, and me and my old mate Crompo played 19 holes of some US course yesterday. Great fun. You set it up through your computer, aim your projector at a blank, in this case blanket we put up against a wall in his garage, and whacked balls at it. And nice way of passing a couple of hours, getting a bit of exercise, maintain our distance, of course. Thanks, guys, for the comments. Have a good evening or afternoon. Steve Davis, you need a beer today as well. You may well be right. The old comment was it was always that the Irish were the best dowsers. Apparently, a lot of the southern US oil finds were found by Irish dowsers. Don't ask me why the Irish were so good at dowsing. I don't know. Ian, I got it from Amazon. Got to keep my daughter in a job because that's who she works for. Well, she works for AWS, but if you just Google golf simulator, it's like I said, I'm not advertising any particular manufacturer, just the one I got because I read all the reviews. It's called OptiShot 2 and it's brilliant fun. You just basically got a load of sensors before and after the ball, and you calibrate your club, holding it at different angles as you swing it, and it works out the different angles of your club. So it measures your club toe, angle, face, speed, all that kind of stuff. You can whack a real ball if you want. They send it out with practice balls. In fact, you can whack no ball at all because it's actually just measuring. So you could actually have a duff shot and it still thinks you've had a pretty good one, which is great for me because most of my shots are duff. But yeah, it's great. OptiShot 2. Good little device. Got it off Amazon. And we just use this laptop and one of my normal projectors I use for training, and we just aim it at a sheet in the garage and just whack balls into the garage. We've lost 3 so far. I'll have to go find them in a minute. But we've got the back 9 to do tonight. The only downside, it's not very good in direct sunlight. You can't really see anything. But if you've got a nice big house, it recommends 8.5 foot ceilings, whatever that is in metric, getting up to about 3 meters. So if you've got an old house, you can probably play inside. Yeah, Steve, I agree with you. I think Guinness might be the answer. I think that's us done, guys. And I think we're just about, yeah, we're a few minutes left before it closes off. Yeah, you can find one, Ian. I can really recommend it. It's great fun. It'll certainly, I mean, you can practice putting on it. You can just, you can practice driving. You can go to a driving range and just practice driving. You can turn off ball tracking. So when you there isn't a putting green as such, but you can play a par 3 hole, turn off ball tracking, putt. And then if you turn off ball tracking, it comes back to where you started, and you can see your grouping. What I would recommend is if you're going to do it and get one, and you do the putting, use a proper ball, because the little practice balls, it doesn't slow your head speed down, so you end up knocking the ball 20 feet past the pin. So we found that putting with a proper ball is a lot more accurate. Other than that, guys, I'm going to sign off now. Thanks again for your attention. I hope you found it worthwhile. If you manage to get hold of one of the simulators in, it's great fun. I should be on commission, but I'm not, but it is great fun. And I'm going to go play another 9 holes in a minute when the sun goes down a bit and we can actually see what we're doing. Might catch you again, guys, on a later webinar when we do something else. Thanks very much, guys, and I'm signing out. Cheers.